Hi everyone. I hope you all are doing well. So just to be just to confirm, am I audible? Just type in from which part of India you all are joining in the chat. You can mention from which part of India you are joining in. That will be great. Am I audible right? Hello. Okay. Cool. Thank you for joining us today. It means a lot to us. So, for those who are joining me for the first time here, let me give a short introduction about myself first, and then we will move on further with the session. So, my name is Priyanka Prasad, and I am one of the organizer of BUGTRON 2.0. And apart from this, I'm a postman student lead, and currently I'm developing a developer community called DEVSTRONS. Now we are more than 1,500 members on Discord. So if you haven't joined our Discord server, make sure you join our Discord server. So once again, I welcome you all to this BUGTRON Con series. But this is powered by Prepinsta and streaming partner StreamYard. And obviously, this is brought to you by DevStrons in collaboration with LWC. Just to give a short introduction about the DevStrons community. So this is an open source community from where we learn from each other. We have some open source project. You can go through the GitHub. We have a lot of project which on which you can contribute. Now, coming on to the main part, that is the Bucktron, for which we all are here. So, let me give a short introduction about Buctrons. So, this is an initiative by DevStron. It began with the mindset of encouraging community folks and making them aware about the edtech industry by putting the emphasis on problem solving, code efficiency, code optimization, and basically logic building programming. So, if you haven't registered for the Buckton contest, the links are there in the description. Do check out the description and register for the Buckton contest. So, if you are not there on Discord server, make sure you are on Discord server. We are also giving away some swags to the top volunteers. So, if you are there in the top volunteer list, you will get some swags, that is GitHub t-shirt as a giveaway. You can check out the announcement channel in our Discord server. So, yeah, that's a short introduction about Bucktron. Now, we are back with the fifth session of Bucktron Con series, but with the same energy, but obviously with a different topic. So, today's topic revolves around Rust, WebAssembly, and blockchain. So let me introduce today's speaker, Faisal Ahmed. Talking about Faisal, he is open source contributor, also mentee in Linux Foundation. He is also MLH fellow. And so, Faisal, can you brief us what we are going to learn today in this session?
Yeah, firstly, hello everyone. Hello Priyanka, and it's
Hi.
really an honor to be invited to speak over here. Yeah, I think in today's session we will be kickstarting with Rust, doing some basics of Rust, a very fast or a very quick basic tour of Rust, as well as understand how the recipe of Rust, WASM, and blockchain is something you are seeing common. So those who are new to Rust or those who are already doing some Rust programming, I think it's for all. So yeah, this is what the session is going to be about.
Okay, cool. That's awesome. I hope we all will learn something new. And this technology also is new for me. I'm looking forward to learn about the getting started stuff. Now the stage is all yours. Let's get started with the session. We'll go the backstage.
Yeah. Yeah, hello everyone. Yeah, I think I already introduced the topic. Uh, I think I'm going to introduce myself again because I had this slide already. I've a little bit about me and Rust. So I've been programming in Rust for over a year now. I started almost in January last year, and I am a junior Rust engineer at Polkadex, where I mostly work on Rust testing and Thea protocol. Uh, just a sec. Yep. And I think there's some latency. And I think I'm also an author at Educative Inc., where I'm actually working on articles related to Rust and data structures. on how you can apply Rust to various common algorithms that you use in C or C++. And I've been a part of the LFX mentorship, where I primarily also worked on a Rust project. And lastly, I have been an MLS fellow. So you can find me on Twitter at Felix Faisal 46. So yeah, I think we're done with the intro. A little bit about this session. So I think, like I already said, that we are going to be exploring the recipe of Rust WASM in blockchain, and how this recipe has become the most common recipe that you would see around in today's world. So if you were to go to LinkedIn and type Rust for jobs, you would 9 out of 10 jobs would be around blockchain. So yeah, I think that is a good estimate, and that is why this recipe has, you can see it commonly everywhere. So let's get started. So let's understand first what is Rust. And if you go to Rust's official website, rustlang.org, it is a language empowering everyone to build reliable and efficient software. I think this might be very confusing for most people. Yeah, but it is in ways it is true, and it. I think you will know this definition. I think once you start working in Rust or start programming in Rust, that it really does empower you to build reliable and efficient software. What Rust exactly is? So it is a statically typed languages. That is, you have to define all the types at compilation time, unlike dynamically typed languages like Python or C++. It provides memory safety. If you do not know what memory safety even means, don't worry. I think we will cover that as well. It is fast and reliable. So basically, it is faster than probably Java, as Java is memory safe because of the garbage collector, while Rust also provides memory safety by not using the garbage collector, which makes it fast as much as C or C++. And I think one more feature is its amazing interface with C and C++ that makes it easy to use with various bindings. I think we will look into what memory safety is right now. Memory safety is actually the most common vulnerability you can find in almost major software companies. And it also includes companies all Fang, Mang, or Manga. Almost every software has memory safety problems. And if you go even at the lower level, if you would go to the kernel level, even at the Linux kernel level, there are a lot of memory safety issues. So what are some of the most common memory safety issues that you can see? And so the memory safety issues that most common are, that I think as beginners that you would relate to, is the use of uninitialized memory. So you declare something and then you try to use it somewhere. And then there's things like use after freeing memory, you try to use it. There's buffer overflow, there's buffer underflow, there's a dangling pointer or a while pointer, something that's not been removed. And I think all of these lead up to a condition called as data races, where variables value is actually changed when it's not supposed to be changed. And all of these issues are actually solved by Rust by these ways. That is, Rust has a system of borrow checking, and it has this whole concept of rules of references, through which only a certain amount of references are possible, or there can only be a single mutable reference. There is a whole concept of smart pointers that completely avoids while pointers and dangling pointers. There's a concept of lifetimes and ownership that ensures that everything is, the memory is properly managed. And lastly, all of these checks are happening at runtime. All of these checks are happening at compile time. So basically, compile times are much higher than what you would see. Compiling a C++ or C program is much faster than compiling a Rust program, because all of these checks are happening at compile time. But the good part is that once Rust is compiled and once we have the binary, it is a production level code, and most of the time you're sure that you won't run into runtime issues. So some more nice things about Rust is that it is the most loved programming language for 6 years in a row by Stack Overflow. I think most of you here are beginners, and I think you have been to Stack Overflow at least once in your lifetime, where you found a solution for something that you couldn't find. So I think when Stack Overflow votes something as most loved programming language, so I think that does matter. It has an amazing package manager. A lot of us actually use Python or JavaScript for development, which have their amazing package managers such as pip or npm, and that is why Rust, even though it's a low-level language, it excels because of its package manager, which is Cargo, and it also has amazing tooling around it. So, for example, Rust FMT, there's Clippy. I think Rust FMT allows you to format Rust code easily without having extensions or whatever. And the learning resources for Rust are actually open source, so you can find unofficial docs, official docs. They're all tutorials, Rust by example, so they're all free and open source. And I think I will be sharing all those links in the Discord of BUGTRONS. And lastly, it is the community. The Rust community is probably the best community out there, where you can get help for almost everything. I think during my initial time, I think the first, I mean, even now, when I have a doubt, I go to Rustlang's Discord server and I will ask the question, and I think I will get almost an instantaneous reply. So that's what's really amazing. And also, the replies are something in a way that they don't demotivate you. They are almost there to help you. And I think I really love that as a community where I don't feel inferior, where everyone wants to learn. So let's go ahead and let's have a super speed tour of Rust. So I think I would like to give a disclaimer that this is not really an in-depth. We won't go in depth about basics of Rust. So I will be sharing you links for that, where you can go through the official book of Rust, where all these things which I'm saying, which might sound really, really confusing to you if you haven't used Rust or never heard of Rust. So yeah, I suggest that you go through the Rust book after this seminar webinar. So let's start with writing a hello world in Rust. So as you can see, a function main is actually, we write it as fn main, and then we create a variable using the keyword let, and then we do a colon and we tell the type. So here I32 means integer of 32 bits, 32 bytes, which is equal to 10. And then we have println. Now you can see in println we have an exclamation mark. This exclamation mark signifies that it is a macro. So there's a lot of macros in Rust, and for now you don't need to know much. Think of it as a black box right now, which is responsible for printing it to the console or to the terminal or whatever output. And yeah, so this is a basic Rust program. And as you can see, another thing that we have defined a variable let x, and by default it is immutable, meaning I cannot change the value of x, which has been set to 10. So in order to make the variable mutable, I'd have to write something like let mute x, meaning that variable is mutable. If you do not know what mutability means, is that mutable basically means that you can change the value of the variable. Immutable means you cannot change the value of the variable. So structs. So I think folks who have used C or C++ are pretty familiar with what structs are. So here, this is how structs are defined. So I'm actually defining a struct called mobile uh, with fields RAM, which is U32, which is which is I'm sorry, which is an unsigned 32-bit integer type, and then the storage, which is also U32, and I am keeping a field called face ID, which is bool, which tells true or false whether it has face ID, and then we can also define associated function. That is, as you can see over here, when I say IMPL mobile, it means implementation mobile. And then under that, I can have associated functions. So I can see over there pubfn, so which means public function is face ID available. And when I do an ampersand self, it means it's an associated function. And as you can see, there's an arrow over there, arrow bool. So that means the return type of this function is bool. And then down we have self.face ID. Now you can see over here that I do not have any semicolon. any return keyword, because in Rust, when you do not have a semicolon at the end of a variable or whatever, which is also at the last end of the function, it means that this is going to be returned. So basically over here, self.faceID will be returned. And let me give you another example of a struct, which is struct laptop. So again, a laptop will have RAM U32, storage U32, webcam Boolean, because some laptops these days choose not to have webcams. Slotted RAM, does it have a slotted RAM or not? So these are all the fields and many more. And then again, in the same fashion, we have implementation laptop, and then we have a public function is RAM upgradable, which returns self.slotted RAM. So basically, when you have a slotted RAM, you can upgrade the RAM, and when it's not, you cannot. So that's why we are returning self.slotted RAM. So I hope that these structs definitions are something that you are able to understand, even if you've been able to slightly understand or slightly make sense of it. That is fine, because now we will move on to what are traits. So basically, traits are a collection of functions that are actually shared by different structs. So, for example, I can define a trait using the keyword trait device, and then fn size of RAM is the method signature, which is basically telling that any struct having this trait should have this function fn size of RAM, which should return a U32 type. And you can also at the same time have default method definitions, such as size of storage, and which instantly returns self.storage, which is a U32 type. So yeah, again, this might feel very confusing as well, but again, this is like a very speed tour so that you can understand a little bits, and what you do not understand, you can read through the Rust programming book. So these are traits, and how this is how you would implement a trait for a struct. So like I already defined a trait called device, and now I'm going to implement it for laptop. So I can just do implement device for laptop, and then I'm gonna write the entire implementation of size of RAM, which I want for laptop. And again, you have, although I had a default implementation over here, which sends the self dot, which returns the self dot storage. I am overriding it uh, using, again, calling it, and then I'm changing the return type to be self dot storage plus 20. So yeah, these are not great examples, but sort of gives you an idea about what traits are. And then we have generics and polymorphism. So those who are sort of familiar with OOPS or object-oriented programming have some idea, and those who have used languages that have generics also have some idea about what generics mean. So generics, as the keyword goes, it is used to generalize types. So by using traits, we can generalize certain types. So I have this function, which is the name of the function is largest storage, and it takes this generic parameter p, which has a single trait device, and then I have device one, device two, which returns me the largest storage device. So this way, I do not have to implement a separate function. I can just compare two structs having the trait device. So suppose I have a mobile phone, which is a completely different struct, and I have a laptop, which is also a different struct. So over here, I can just do if device one dot size of storage is greater than device two, then I'm returning device one, else I'm returning device two. So this is one way that you can reduce a huge amount of redundancy in code, and also use object-oriented programming concepts. And also at the same time, as you see that size of storage, since size of storage is part of the device trait, that is why we are able to call over here. So whichever trait that we're using, it needs to have its function. So I cannot call functions over here such as is it does it have face ID, or is RAM upgradable, because those are specific to the laptop struct. not the device trait. So I hope this makes sense. And I think the next concept that we will be going through is enums. So in enums, you can have multiple values. They are basically almost most of them map to a U8 or a U32. So you can have something like relationship status, single, committed, complicated, and or if you're a programmer. And then I think enums are actually common in most low-level programming languages. But what's different with enums in Rust is that we have enums with data. So as you can see over here, we have enum types, which is number I32. That means inside number encapsulated is an I32 type. And then we have string. Encapsulated inside string is a string type. And then we have boolean. Encapsulated within boolean is bool. Now, in languages like C, C++, or even Java, it's almost impossible to create an array having different types. They are usually homogeneous. But in Rust, using enums with data, I can ideally create an array having different values. So for, as you can see over here, I have this add, which has a type number as well as a boolean, all stored in a single array. So that's really cool. And the next topic that we have is option and result. In Rust, by default, you do not have a null value. So the way things are handled is that they use none or they use error to do all sorts of error handling. So basically, option is an enum that has this generic parameter t. So an option can either be some or none. So basically, the output of the return type of a function can either be something or it can be nothing. So sort of like that. That's how option goes. And then there's enum result. So the output of a function can either be something that's okay, we've got the right output, or it can be an error. So encapsulated within them are the types that again, as I explained about generics. So you can also encapsulate them inside enums. So I think a good example is over here, search for a number, where I'm passing in ampersand. I32 basically means that it is an array, and it returns an option I32. So what does this option I32 mean? So it means that it can either be some I32, that means it has the, it has successfully found the number, the index of the number, or it can be a none. So that is what option does. And then we have another example for result. So we have withdraw, and over here we have amount. So basically, if that amount, if your balance is greater than that amount, then you would get the result as okay, and this is your remaining balance inside a U32, which is an unsigned 32-bit integer. And then if your balance is less than the amount, then you will get this L inside which you will have insufficient balance. So this is it about options as well as results. And I think with this we come to the end of the super speed tour of Rust. Uh, I'm not sure if there's one more. Yeah. With this, we come to the end of this super speed, very small, whatever you call it, or a tour of Rust, where we went through some basic concepts that are used often. And yeah, and if there are any questions, you can shoot it in the chat. So I think now that we covered over basics of Rust, we understood what Rust does. The way the code is written, how it is reliable, how it avoids memory safety, and all of that. So I hope you keep that in your mind. I hope you retain some of that, because I think, like I said, this is a webinar of the recipe. So now we have WebAssembly. So WebAssembly is basically a portable platform that it's basically a portable compilation target that is, as of now, widely used in web browsers. But it's not specific to web browsers, as you can have VMs and many other things, because it's a compilation target. So a little more about WASM or WebAssembly, that it has a polyglot runtime, that is, you can have multiple languages compiled to it. it is actually run in a sandbox environment wherein you can actually ensure memory safety and make sure that the code is reliable and secure. I think the biggest advantage of WebAssembly is its compact nature. Uh, yeah, so I think of compact, the basically the binary is so small that when you have low networks, whatever website you're using, if they use WASM, then it's going to be much faster if they use it because the size is very small, and it is reaching or approaching native speeds, near native speeds, and yeah, that is about WASM. And I think at this point, I think it's a good time to take questions. I think Anshuman just said me up. So I think I can take questions right now before we move forward so that uh, folks can have some clarity. So yeah, if you have any questions, then you can shoot it in the chat. Huh. So I don't think there are any questions in the chat. So uh, I think we can continue then. Uh, so, like I already said, that WASM can be compiled from C, C++, Java, JavaScript. So, why do we have to use WASM in Rust? Why is this recipe that has been, most popular? And one of the reasons is the package manager is Cargo. There are amazing crates out there for WebAssembly. It has an amazing community of Rust. So if you see that something that's new, a new language often has a very vibrant community where folks are learning more things and different things. And about Rust is that, like I said, since WASM runs in a sandbox environment, ensuring safety, Rust also ensures safety, but both in different ways. And also Rust can be used in multiple things. So this is the reason why WASM and Rust really gel well together. Uh, yeah, that is why this recipe is something that's working very well. And then let's do a very short demo of how a Rust program would look like, which we will compile it to WebAssembly. So over here, this is basically a basic WASM Hello World program, and I think this is pretty intimidating. So basically, use is like importing modules. So we are importing all modules of WASM bindgen. So this is a library that we will use to compile to WebAssembly. And then you have this hashtag WASM bindgen. So ignore this as of now. Think of it as a black box or a magic box that does all the underlying work. And then over here we have extern pubfn alert. So that basically means that we are using an external JavaScript function. So we will be calling an external JavaScript function alert. So I think most of you might know what alert function does in JavaScript. It basically alerts in the browser. So we are basically calling that in this function. And then we are also defining another Rust function. So we have again a macro, awesome bindgen, that takes a greet, which takes in a string. I think if people are confused about what ampersand str means, it basically is a string. So again, you have this function greet that takes in a string, and then we are using this external function from JavaScript, which is alert, using some Rust magic tricks, that is format macro, where we are formatting the output. So this is how a very small hello world program looks like in Rust, which we are compiling to WASM. So once we compile it to WASM, you will get a package called hello awesome package, and then from the root directory you can actually call this function. So as you can see, script, you have you're importing greet from package hello awesome.js, and upon initializing we are actually calling this Rust function we just defined in the previous slide in JavaScript. So yeah, this is what awesome does. And then you can see the output. So if you run the server over here, the index.html, you can see hello WebAssembly, And then you can also see the logs where you can see that it's calling the WASM binary. That's a WASM bg dot WASM, uh, the last line in the logs. So I think the reason why I'm not doing this, hands on, is because that might be something you would have to follow a lot of things. So think of this as a very small demo or how things actually look like. And I have the article for this entire demo, and folks who are interested, I will be leaving all these links in the Discord. So this is basically how you compile Rust to WASM, and then we are running it on the web browser. Now, the advantages of WASM are many when used with web browsers, but they also depend on the architecture of your web application. So sometimes there are case studies where people have replaced using JavaScript to WASM, and they've gained almost a 20x performance boost, while some places where using WASM has reduced the performance. So saying that WASM is better than JavaScript really depends on the architecture of your web application and how you're using things. So yeah, so that is all about WebAssembly. And I think lastly, I'd like to also clarify that WebAssembly doesn't really mean assembly for the web. For me, basically, because it's not just used in web browsers. It is a portable compilation target that you can send it to any computer, and it executes with near native speeds. So think of it as an assembly that can be shared easily through web. So that is a better way of understanding what WebAssembly is. So now I think we've come to the third part, that is blockchain. So a basic, definition of blockchain in a single sentence is that it's a digital public ledger held on hundreds of thousands of computers. So I think before we begin this part, if there are any questions, then shoot it up on the chat, and I'll be happy to answer them. So yeah. But actually before, okay, so this is a question by Anshuman. Uh, so I think it's a like I said, this question about is Rust going to replace Java? So that is something that I would not like comment on, because this webinar is focused on Rust, not whether Rust is better than X programming language. Java will continue to live on in its own use case. For example, like how technologies like PHP and all live on, but definitely Rust is something that is gaining momentum. And if people choose to migrate to Java, migrate to Rust, then no one's going to stop them. And yeah, I think
Uh,
that answers the question. Yep.
we have one more question from Gulam. So Rust is mostly used for creating backend. Is there any framework in Rust with which we can create front end? This is one of the question from Gulam.
Yep, I think you can't directly create front end in Rust. I think you can create it through WebAssembly, as I described how the demo went, where you can create JavaScript function, basically converting Rust into JavaScript. So that's the only way you can use Rust in the front end. And I think JavaScript is something that is widely used in front end, and that's not going to change. So probably Rust in the backend will replace JavaScript in the backend, but JavaScript in the front end is the king. So yeah, that answers your
Okay.
question.
Is there any more question? Feel free to drop in there in the comment section.
So yeah, I think so. I think the silence meant that there are no more questions. So about blockchain, I think I can give the single sentence definition that it's a public ledger that's held on thousands and thousands of computers. And this is not going to be a blockchain 101. We're not delving into how blockchain exactly works, or how Bitcoin works, or even which cryptocurrency that you have to invest to get the highest gains. So that's not all going to be covered here. So basically, We are going to see how we already talked about Rust, we already talked about WASM, and how they are solving certain things, and how they actually fit into this recipe of blockchain. So, how does Rust WASM blockchain fit in? So, this is the final third. So, let's understand some history of blockchain. So, blockchain was actually created through Bitcoin. So, when we found when Bitcoin was created, uh, Bitcoin, the technology behind Bitcoin was blockchain, and Bitcoin was basically a value transfer system. But to do any more advanced applications of blockchain, Bitcoin, had a lot of performance and scalability issues, and that's when we had Ethereum. Now, Ethereum was, introduced smart contracts, which is actually, if folks don't know what smart contracts are, it's basically an agreement between two people, which is executed upon certain conditions, and it's safe. And other than smart contracts, Ethereum had this whole decentralized application. So it had a platform where you can have dApps, but the expansion of blockchain networks requires scalability, security, and efficiency. So these are three things that are often the crux of any blockchain development, that is scalability, security, and efficiency. And I think the last point is also to portray this how a normal developer was versus a blockchain developer. So I think there is a big transition from being a normal developer where you do not, on a daily basis, do not think about these things, while a blockchain developer has to always keep making decisions for scalability, security, and efficiency, keep making trade-offs almost every day. So this is the difference between a normal developer versus a blockchain developer. And another type is, if you do not know, I think a lot of beginners might not know, is that there's one more that's called kernel developer, and they are another kind where you constantly use C, and for them, efficiency, speed, and memory management is much more important. So you can see that the difference, that certain developers prefer scalability, security, and efficiency than others, mostly because of the domain. Like I said, the blockchain networks require these things where on a daily basis, where you need to do this trade-offs, or else it could lead to huge problems where people could lose cryptocurrencies, and that is something no one's going to take lightly. So that's some background about blockchain and where we are at, where we need scalability, security, and efficiency better than what Bitcoin or Ethereum provides. And yeah, so finally, we come to this part where how does this all fit in? Now, I already told you that WASM make sure that memory safety is ensured in a sandbox environment. I also told you that Rust is fast, secure, as well as it avoids all memory safety problems, as well as it does not have a garbage collector, which makes Rust really fast. So we have Rust and WASM. And the final third, blockchain. So blockchain requires efficient and reliable code. As I mentioned, that those are the most important parts for any blockchain. And why Rust? Because it has straightforward compilation to WebAssembly. That's one of the reasons. And I think I already told you the reasons why someone would use Rust. I also told you why someone would use Rust with WASM. So I think that speaks for itself. And then we have Solana, which is a modern blockchain, which also is built on Rust. And then we have Substrate framework. So Substrate framework is basically a framework that has been written in Rust to create blockchains, and that was actually used to create Polkadot, which is also another blockchain networks. Smart contracts in WebAssembly. This is important because most smart contracts are written in Solidity, I guess. And the problem with Solidity is that you cannot use Solidity for anything other than smart contracts. So, if as a student you were to learn Solidity and write smart contracts, you are probably going to be, that's going to be, suitable only for that. But having smart contracts in WASM gives you the flexibility to write contracts in Rust or C or C++ or whatever. So that way you are learning languages that are, in the future you can use it on different things. And then the nodes in blockchain actually run modules in WASM format. So this also has a huge advantage. And finally, I think Ethereum actually uses EVM. For many years, it is something that hasn't been able to scale. And so, right now, for good folks at Ethereum are planning on replacing EVM to EWASM. So that's what's happening with you know WASM and Rust in blockchain world. And I hope by the end of this session that most folks were able to understand how this recipe works together, and I hope they were able to retain some of the information and how these all together are the most common recipe. And if you were to, again, like I said, if you are a Rust developer, then you will probably have this question: why are all the jobs related to crypto why are all the jobs related to crypto require Rust? And those are some of the questions I'm answering here. And also at the same time, folks who are interested in blockchain, and they also might need to take up Rust, because again, like if you go and go to LinkedIn and search for a job related to blockchain, uh, probably 7 out of 10 times it's going to have Rust and WASM inside the job description. So yeah, so these are the recipes for the modern blockchain developer, that these engines will be responsible for all the future blockchain. And I think with this we come to the end of this session or seminar. And if you have any questions, so you can shoot me, or you can find me at Twitter. And I will also be having a course on data structures in Rust in the future, via the educative platform, and I will be sharing all of that on Twitter. So if there are any questions, so then you can shoot it. uh, I don't think there are any questions.
Uh, Definitely, feel free to drop in the question if anyone you have any question.
So I think there are no questions.
I
But
guess
yeah, again, it's great to come back here and talk via in this event.
cool.
Uh,
Thank you
and also at the
for
same time, yeah,
session.
yeah, I think I would also encourage everyone to register for BUGTRONS. It's an amazing event. It's an amazing community, and I've been here for a really long time. Uh, I think there is a question now. If I want to
There's a
start
question. Yeah.
development, yep. So it is by
If I want to
Aditya.
start,
So if you,
yeah, this is where it. If I want to start
yep,
the development in blockchain Ethereum,
uh,
uh, it's the best to start, and then we can move on towards the Solana or Rust. Yeah, which is the best?
Uh, yep, I think to be honest, language shouldn't be a barrier for you. So, sort of like Rust is the engine. If you feel Ethereum is something that you're already comfortable with, then you can move ahead as long as you know how Ethereum works. And with Ethereum 2, with EWASM, Ethereum is going to be scalable in the future as well. Probably, maybe you don't know how scalable it will be in compared to Solana or other networks. So that's one thing. But definitely you can learn Rust, because it's a language that's really good. And if you're someone who's interested in who's probably used C or C++ or Java, then using Rust will be a treat, as well as using the package manager. So I think, yeah, it's really subjective, and it would depend highly on what you would prefer. Yep.
There is
So
one more question by Anshuman, I guess. So, can I see your work in ft.io? Like, can you brief us about what it is, ft.io?
uh, yep. So I think FD.io is actually my mentorship with Linux Foundation. So FD.io actually comes under LFX. So basically, the work that I did was creating Rust bindings for VPP. And VPP, I think this becomes very high level. So I think I'll not
The
explain it much. But
terminology.
basically, Yeah, so basically, it is about networking, and where we had this software which was written in C, and basically my work was creating bindings for that, that software in Rust, so that I can call those C APIs using Rust. And yeah, I think the entire time that was the work, and then making the code. Like I said, Rust has a lot of features, but one of the most important features that a lot of Rustaceans focus on is the readability. So if I was to write a binding for C in Rust, so what was the most at most important was that it should be really readable. That is ergonomic code, and that is what I focused a lot on. Yeah, and like I said, I think I showed you this whole thing of macros. I don't think a lot of you might have caught that, but these macros actually are responsible for making the code ergonomic. So yeah, I worked on macros and a lot of things. So a huge steep learning curve over there. Yeah, so that was all about
Yes.
my work.
Yes, this answers the question. We have one more question, like which uses from Gulam. Can you brief us on the use stack, like which uses Rust for UI building?
Yep, I think UStack is actually a WebAssembly framework. I think I encountered this around last year, but I'm not sure how much the library has changed. Probably it has matured. So basically, using you can basically have like there are macros that will make the code feel more like React. So if you're someone who wants to create new WebAssembly related projects, then U is something that you can use, as it is the syntax is very close to React. And the reason why I haven't used it much is because I discovered it at a very initial stages where it had still a lot of problems. But I think as it has gained momentum, I think it has matured right now. So yeah, it is amazing if you want to use it.
Okay, so we have one more question from Aditya Sahu. So, what do you think if I want to learn the blockchain beginner concepts like timestamp and all? So, can we learn these things in Solana blockchain?
I think these concepts are actually universal. So in the sense, for example, time complexity is same whether you use Rust, Java, or even C++. Those concepts are not going to change. So I think these are not specific to Solana or Ethereum. So I use the Substrate framework on a daily basis, and I read these concepts on a daily basis. So you can learn these concepts however you like, but you will be implementing these regardless of which blockchain you work with. Or if you're only focusing on writing smart contracts, then maybe not much. But yeah, so I think these concepts are universal, and you can learn this whether you use Solana or whether you use Ethereum or anything. So yeah.
Yes, this answers the question, and we have a compliment from Anshuman. Like, thank you for the session. Mm,
Yeah. Awesome.
we
So I
have
think
some. Oh,
again, a huge shout out to the again organizers of BUGTRONS for I think inviting me to talk, because it's really amazing. And
super
folks who
cool.
are here, yeah, folks who are here, please join Buxton, because I think initially they are also known as DEVSTRONS. So that this is a
Yes.
community that I've been a part of for a really long time, I guess, as of now, and they've done some amazing things, and there's a lot more to come. They're just getting started. So if you've not already joined the Discord, or if you've not already registered, then what are you doing? So start, I guess, register and join the Discord community. So yeah.
Thank you for the session. We will be back again with another session. And thank you all for joining this session and being a good listener. And here is the registration form for BuckTron 2022.